Okay, everybody, it's Mr. Clausen here. Just wanted to go through a problem with you. Two people are pushing on a sled that has a mass of 50 kilograms. One person pushes to the right with 150 newtons, and the other person pushes to the left with 35 newtons. If there is 20 newtons of friction, what is the acceleration of the sled? So this is a pretty standard physics problem. Best thing you want to do here at first is just go ahead and start to draw a picture to help illustrate or help you figure out what's going on with. Okay, so this is what we got so far. Person 1 is pushing to the right with 150 newtons, and person 2 is pushing to the left with 35 newtons. You can think of this as like you're out sledding with your little brother or sister. It's time for you to go home, and your little brother is like, no, I don't want to go home. So they're pushing back and trying to go. But you're the bigger, older brother or older sibling, so therefore you're going to win. What we need to do is figure out where this 20 newtons of friction is going to go. Is it going to go forward, or is it going to go to the left or to the right? So if you take a look, which one of these is going to win? Well, you, being the one at 150, are going to be able to overpower your younger sibling. So the friction is going to go opposite of the motion. If you're going to the left, to the right, then friction is going to go back to the left. So we would show that here with 20 newtons of friction. All right, so now we need to start figuring out what's going on for the acceleration of the sled. So to figure out acceleration, what we would need to know for acceleration is equal to the object's net force divided by its mass. Now, if you take a look in the problem, it's really easy. We have 50 kilograms, so we can go ahead and put that in right now. But what we're still missing is the net force. And so in order to figure out the net force, what we need to do first is draw a free body diagram. Okay, so to draw a free body diagram, what you need to do is start with just a single dot. And what it is it's just a simplified picture that just draws all the forces acting on the object. So what we'll do here first is we will start with the forces that we can see. We've got the 150 going to the right. We've got the 35 from the younger sibling pushing to the left. And we've got 20 newtons of friction pushing to the left as well. Now this isn't all the forces that are acting on the object. Remember, this object is on planet Earth, so what we need to include as well is the force of gravity and because it's sitting on the Earth, there's also a force pushing back up, so we have to include the normal force. Now you'll notice that I drew those two arrows the same size because in this case the sum of the forces in the y direction is going to be equal to 0. Now that's just a fancy way of saying that the sled's not moving up or down, so the forces are going to be balanced right here. Now what we should do is, to make our free body diagram more accurate, let's just go ahead and figure out what the force of gravity would be on it. Okay, so I calculated force of gravity. It's mass times the acceleration due to gravity. 50 kilograms is the mass. Acceleration due to gravity is 9.8, giving us a total force of gravity of 490 newtons. Now, like I said before, since the sum of the forces in the y direction is going to be equal to 0, the force of gravity is going to be equal to the normal force. In fact, I'll even put that over here. Okay. So now what we need to do is figure out the net force. Since these two cancel off, the only forces that we have left over are going to be in the x direction. So let's go ahead and figure out what the net force is in the horizontal x direction. Okay, so to figure this out, I use my force equation in the horizontal x direction. 150 newtons is going to the right, so that's positive. And then I added to that a negative 35 newtons, negative 20 newtons, because both of those are going to the left. And when you add that together, you get a total net force of 95 newtons. And we could illustrate that like this. All right, so there is our net force acting on the object. Now that we know that, to figure out the acceleration is pretty simple. All you have to do is bring that number up here. Run that through on your calculator. And you'll find out that the acceleration of the sled is 1.9 meters per second per second. All right, everybody, it's Mr. Clausen here. Just wanted to run through another sample physics problem with you. Don't worry about why you would do this with the helicopter, but what we have here is a 17.5 kilogram ball dropped from a helicopter. At some point later, as it's falling down, we find out that it has an acceleration of 3.2 meters per second squared downward. The question is asking what would be the force of air resistance on the ball in order for its acceleration to be only 3.2 instead of the 9.8 that you would expect. All right, so the first thing we got to do here is, in order to figure out the force of the air resistance on the ball, is we're going to need to draw a free body diagram and figure out the net force on the ball. So let's just go ahead and draw a picture to see if we can figure out what's going on with this. All right, so this is what we got. Now you'll notice that I drew it in such a way that the ball is going down, so we have a very large force of gravity, which we can go ahead and figure out here right now. All right, so knowing that the ball is being pulled down by gravity, if it has a mass of 17.5 at 9.8 meters per second squared, this would give us a force of gravity of 171.5. Now what I was going to try and say is, you'll notice that I drew the air resistance arrow a little bit smaller. Now why did I do this? It's because up here in the problem it said that the ball is still accelerating downward, which means it's got to be feeling a net force in the downward direction. The only way that that would happen is if the downward arrow was bigger than the upward arrow. So we know that the force of air resistance has to be smaller than this number. The question is just how much. So in order to solve this problem, what we could do is, if we could figure out the net force, then we would be able to do that. We do that first by writing a net force equation. All right, so here's our force equation, or our force statement. The net force acting on the ball would be equal to all the forces that are acting on the ball added together. So the only two forces we got here are the force of gravity and the force of air resistance. The force of air resistance is what we're looking for. Now we already know the force of gravity is a negative 171.5 newtons, because it's going down, that's the negative. So now all we need to do is, in order to find the force of air, we just got to figure out the net force. We might be stumped a little bit here, but don't worry, we do know what to do. Remember, we know that the net force of an object is equal to the object's mass multiplied by its acceleration. All right, so this is what we got. The 3.2 meters per second is coming from in the problem. We know that the ball is still accelerating at that, which means that somehow that the combination of all the forces acting on the object are still causing this 17.5 kilogram ball to accelerate at 3.2. In order for that to happen, it would have to be feeling a net force of 56 newtons. I made a little mistake here. That would be downward for the 3.2, which then just changes this 56 to negative, which I should have caught sooner, but I didn't catch till right now. If you take a look, it makes sense because the net force is going downward in order for the ball to be speeding up. Now that we have this number of negative 56, we can put that into our force equation and solve. All right, so using a little algebra here, all I did is added 171.5 to both sides, and that tells us that the force of air resistance has to be 115.5 newtons upwards. So that's how you would go about solving a problem like this. If the problem gives you the acceleration, it's asking for one of the forces. First thing to do is to draw the net force diagram, figure out what your force equation would be, use F equals ma to find net force, plug that in, and solve for the unknown force. If you have any questions, talk to me in class.